So welcome everyone. Thank you for the introduction. Apologize for the technical difficulties, but let's go ahead and get started. My name is Todd Kelling. I'm the Director of Marketing, Technology, Planning in the Barefoot Switch Division as part of Intel. And I'm happy to join you today to talk about Intel's vision for the data center of the future, and as a part of that, the Intel Intelligent Fabric. And along with that, I'll talk to you about how it relates to P4 technology, the subject of our workshop today. Next slide, please. In terms of an agenda, first I'll talk about our vision with the Intel Intelligent Fabric and the data center of the future. Then we'll go in deeper on three key technologies: the P4 programming language itself, in-band network telemetry, and then congestion control with remote priority flow control. That'll actually be our next session after this. So I'll give you a quick preview of that. And then I'll talk about some of the Intel products that embody these technologies and different applications where they can be used. And last but not least, a call to action on how you can get involved further. Next slide. Back in June of this year, Intel unveiled our data center of the future vision. And to do this, you can see there are various compute and servers around the peripheries of this diagram. So general purpose compute, machine learning and AI, computational storage, acceleration services. And the products that drove this were, first of all, the general purpose compute, the Intel Xeon processors, the XPUs, we call them, or these are various accelerators, could be a graphics accelerator, FPGAs, or other devices. And then we also introduced a new processing unit, and that's called the infrastructure processing unit. You can see that in the light blue there. And this was really a new architecture for the data center. And the purpose was to separate the infrastructure and maintenance code from the tenant code, right, for the purposes of security. And so this gives you better performance and enhanced protection between those two entities. Now, to get all of these to talk together, in the center, we have a block called Intel Intelligent Fabric. And this is used to connect at high speed with high security and intelligence, as the name says, these different computing elements within the data center of the future. And so this is what I'm going to dive deep into today, the Intel Intelligent Fabric in the center. Next slide. But before we get to the solution, let's talk about some of the challenges. On the left is a graph of the increasingly growing data center networking traffic, right? That through the 5G, IoT, AR, VR, and of course video streaming, more and more data is being sent across the network. And this is data from IDC, shows it up to 175 zettabytes by 2025. And with all this data, we need to move that, store that, and transport that data and analyze that data. And so there's a lot of work that needs to be done, and the current systems won't be able to keep up. But when I talk to customers, that's part of the problem, but most of the challenges are really around the software. With the move to SDN and NFV, many people are still maybe 50, 75% of the way through that. And most notably, this move to the cloud native architecture with container-based microservices and the orchestration and automation that goes around that. So that's really top of mind for most customers. Also, you have AI and changing workloads requiring growing network optimizations. And more, we're living in a distributed scale out world for both workloads as well as for storage. And as this complexity grows, it gets more and more difficult to root cause any network slowdowns. And of course, you need to ensure end-to-end security. And the cloud service providers, communication service providers, and enterprises as well really need to address all these challenges while maintaining their CapEx and OpEx spending. So our challenge is that network not only needs to increase bandwidth, but it also needs to get smarter. Next slide. And to address this, Intel's vision is what we call Intel Intelligent Fabric. And by fabric, to be clear, I mean basically a leaf spine architecture with optimized connections within the data center. And to address this, we have a full range of products. At the heart of it is the Intel Tofino Intelligent Fabric Processors for intelligent switches, for leaf switch, spine switch, top of rack switch, network packet broker, and other functions. But we also have the IPUs, infrastructure processing units I just talked about, as well as Intel Ethernet adapters, Intel Xeon processors, the FPGAs such as the Intel Agilex and graphics accelerators, and then silicon photonics, high-speed optical connections between all of these. And so we're bringing all these elements together for this optimized fabric. But it doesn't stop there. We want the software to be easy as well. And so we're building on and helping drive industry standards, such as P4 that we're here talking about today, SPDK, DPDK, eBPF, the embedded Berkeley packet filters, and then also SONiC. This is a open networking, open network OS being produced by the OCP community. We're heavily involved in that. And then back in October, we also introduced the IPDK, the Infrastructure Programmer Developer Kit. And that is a common environment for programming these different network elements. And the end goal of these products coming and technologies coming together is, as we show in the lower left, improving the ease of use, making it easier to deploy workloads and modify workloads, addressing the massive bandwidth we talked about on the previous slide, giving increasingly AI-driven self-monitoring, self-analyzing, and self-healing. We've done some good work with VMware and presented at VMworld on the self-healing capabilities, enhancing the security, and then allowing end-to-end optimization with the fabric telemetry, and doing all this while improving the density, the power, and the cost. Next slide. Now, some of the benefits of bringing this together are these products and technologies together are what I call the benefit vectors here. These are areas that we have capabilities today, but we're going to continue to expand and extend in these areas. And the first is intelligence. The second is performance. And the third, which I think is the most unique about this approach, is the visibility and control. In terms of intelligence, we have the fully customizable P4 programmable pipeline, major subject of our talks today. We can also accelerate AI and machine learning workloads. For higher bandwidth, say a terabits per second and above, you can use Intel FPGAs for expanded table and buffer sizes. And then for security, the Intel Xeon processor is very helpful there with the SGX, secure dot extensions for secure enclaves, and TDX for VM isolation. In terms of performance, the Intel Tofino-based switches start at 6.4 with terabits per second with Tofino 1 to 12.8, moving to 25.6 with Tofino 3, so very high total throughput. To get to that rate, we have 112 gig SerDes. We also have the high-speed Intel Silicon Photonics, very, very common, very popular at 100 gig, but now up to 400 gig speeds. And then we have to consider power as well. So with the Intel Tofino Intelligent Fabric processors, we have power-optimized hyperscaler use cases. In terms of visibility and control, we're offering enhanced congestion control. We'll have a talk on that later today. And then we can use the in-band network telemetry, or INT, to identify hotspots real-time to give us clues into what's happening in the system. And then we can analyze those packet flows using the Deep Insight network analytics software, or as well as AI. Increasingly people are using AI for that. And then it's not only important to analyze the data, but we need to receive more and more INT data. And so the Intel IPUs and Ethernet adapters are providing that information, and will continue to do that. So that's a look at the main benefits: the intelligence, performance, visibility, and control. Next slide, please. And at the heart of this system is the Intel Tofino 3 Intelligent Fabric Processor. And we just announced this in October at the Intel Innovation event. And the idea here is to meet this explosion in traffic with 5G and IoT data, as well as the distributed workloads, and accelerate AI, as well as offer edge to cloud visibility. And so it offers the capability in terms of intelligence, performance, visibility, and control. Now, I mentioned that the Intel Intelligent Fabric is geared towards the data center, but it's not just cloud data center. So these characteristics are beneficial in other areas of the network as well. So not just cloud, but also edge data centers, or high performance computing uses a similar technology and topology. And then we see increasingly communication service providers moving to cloud technology. So the COSPs can benefit as well. So the bottom line is that we see a switch to intelligence with the Intel Tofino 3 Intelligent Fabric Processor. Next slide. All right, but it's not just about hardware, it's also about software. And to do this, we've driven this common programming model based on P4 across servers, IPUs, FPGAs, and switches. So it begins with a P4 programming that we'll talk about throughout the day today. But then the next key step, and we announced this at OCP Summit as well, is a common API for all this programming. And that's what we call the table-driven interface, or TDI. And so this allows you to program in P4 and then target it towards Intel Xeon-based servers using P4 and DPDK, doing the ASIC-based CPU IPUs such as Mount Evans, which is a project we partnered with Google on and also announced at Intel on, or you can do FPGA-based IPUs such as the Oak Spring Canyon from Intel. And then, of course, the Intel Tofino-based intelligent switches. You can also use this table-driven interface and the P4 programming. Now, that's all on the data plane. In the control plane on the upper right there in section 3, at the heart of that is the SONiC OS. So this is an open networking OS driven as an OCP project. And at the OCP Summit, we also announced jointly with Microsoft a set of different packet test framework contributions. So we're starting those today, and that'll grow to over 1,000 packet test frameworks by the time we're done. Next slide, please. So now let's go deep into some of the key technologies. Next slide. So P4, obviously you're all heard of and familiar with, or you wouldn't be here today. This is just a key component of the whole solution that we've been espousing and will continue to help lead and drive. We really believe in this, and we're really happy that you're here participating today. The community has grown to over 4,000 developers and 100+ member organizations. And if you haven't already, you can go to p4.org for more information. Next slide. Then next is key part of this is INT, the in-band network telemetry, where you can really watch the packet's journey from beginning to the end. And so for each packet, we can look at it throughout this rather than just doing a ping and getting very slow response with limited data. We can very precisely investigate, why is the packet here? How did it get here? How long was it delayed? Why was it delayed? And we recently opened up this INT capability called Host INT to the Linux community. And so you can use this on any Linux-based host. We also offer the Intel Deep Insight network analytics software that provides flow analysis, provides various probes, and based on this header info that we do add to each packet, but basically that doesn't slow things down too much. But through that, we can gain insight throughout the system. So this is really a great way to examine your system, and then based on that, you can go in and perform optimizations. Next slide, please. Then as an example of intelligence, I want to just present very briefly here this idea of remote priority flow control, or remote PFC. Though this is going through IEEE, it's also being called source flow control, or SFC. This is a way of doing congestion control where here on the left we have the different senders, we have a source top of rack switch, and then we go to on the right there we have the destination top of rack switch, and eventually get to the receivers. And Jeremiah Splendid is going to speak about this in the next presentation, so I don't want to steal his thunder. But if you look at where that microscope is, this is where we see the benefit of intelligence, because there is a technology called PFC, Priority Flow Control, today. It's an IEEE standard. And with that, we can tell when our buffer is full, when the queue is full, and then we can still tell the previous hop, hey, stop sending. But now through the intelligence with the Intel Tofino based switches, we can set different limits or a different trigger threshold, and we can calculate that. And then when we reach that trigger threshold, we can not only send the previous hop, but then we can send it all the way back to the sender. So this is a great improvement, and we'll show you some data here in the next presentation on how this added level of intelligence in that destination top of rack switch can greatly improve the performance with regards to congestion control. Next slide. Now I want to go on and just give you a very quick overview of some of our products, and then talk about how these map to different applications. Next slide. So in terms of the Intel Tofino Intelligent Fabric Processors, this is our roadmap. The first product was the Intel Tofino, and that came out with Barefoot Networks was a standalone company, and that had speeds up to 6.4 terabits per second. Then next was the Tofino 2, and this went into production this past summer, and that doubles the total bandwidth up to 12.8 terabits per second. And then in October, we announced the Tofino 3 Intelligent Fabric Processor, and that doubles the bandwidth again to 25.6 terabits per second. It has a modular chips design, and what that means is to get to that 25.6 terabits per second, there's actually 2 chips, and they're connected inside the package using an EMIB bus interface, one that we uniquely and custom design. So that's how we get up to that speed. For the 12.8 version, then it's just a single chip inside of the package. And this uses 112 gigabits per second SerDes for the I/O interfaces, but it also has 56 gig, which is nice because then that's backward compatible with the Tofino 2. So it makes that migration easy if needed. In terms of the benefits, it's very similar to what we talked about with the Intel Intelligent Fabric. The intelligence from being P4 programmable, the AI acceleration, as well as being highly secure. The performance up to 25.6 terabits per second now with Tofino 3, as well as 112 gig SerDes and power optimized use cases. And then visibility and control with the INT, the enhanced congestion control, and some of these self-healing network capabilities. Next slide, please. In terms of applications, because these devices are programmable, they can be used for a wide range of applications. So of course you can do it for enhanced routing and enhanced switching as shown on the top, but also a wide variety of specialized applications. For example, in the communication service provider space, network packet brokers, broadband network gateways, or the user plane function. Another good example using both the Tofino Intelligent Fabric Processors as well as Intel FPGAs is the layer 4 load balancing and acceleration. Petr Kastovsky from Intel will give us a talk on that towards the end of the day today, so we'll give you more details there on that one. Next slide, please. And since many of you are involved in the academic community, I want to mention a special program that we have going on right now. We call the Fast Forward Initiative. This is a part of the Intel Connectivity Research Program, and through the end of the year, we're accepting applications for hardware grants. And the idea here is to do this advanced P4 programming and testing. It often requires more than just one switch. You really need a cluster. And we realize that that can be difficult for universities to put all those pieces together. So we're accepting applications from ICRP members for hardware projects focused on the programmability, intelligence, performance, visibility, and control. And so the case here is where if you buy some switches, we can offer a grant to give you some more switches, as well as to give you discounts from some of the participating vendors mentioned here. So if you're interested in this, I recommend you get an application in by December 31st. Next slide. Okay, and so just to wrap things up, ways you can get involved and help continue this research and move things forward are, first of all, by joining the P4 community at p4.org. If you're interested in the networking OS, there's the OCP Sonic. If you haven't already, I highly recommend you join the Connectivity Academy for training or the Connectivity Research Program with the special Fast Forward initiative that we have going on right now. And then if you want to learn more about the Intelligent Fabric processors, you can visit intel.com/IFP.
Okay.
All right, that concludes my talk.
Okay, thanks. Thanks, Todd, for giving a wonderful overview of the Intel Intelligent Vision and related technology. I think we have a few minutes for the question, to see if any question from the audience here, from the floor here. Anybody want to ask questions? Hey, Todd, I have a simple question. Since the Intel Intelligent Fabric support different backups in the software models, could you elaborate more? Can you give us more example for each? Todd, can you hear me?
Okay, I caught part of the question. You talked about how we service different applications, and the question was about software. Is that correct?
Yeah.
And you're looking for more specific examples?
Yes.
Okay, in terms of the application software specifically?
Yeah, just give us an example for each of them.
Yeah, I'll give you. Let me just give you a couple. Like I showed earlier on that one slide, there's a wide variety. But I think one great example is with the cloud gateways. This is something that Alibaba did, and they separated into both a hardware and a software-based gateway, and that way they were greatly able to improve the traffic for their Singles Day. As example, and this was called the Sailfish application, and they talked about that at SIGCOMM. The layer 4 load balancing, this is one where we have some software that will help with that. It's P4 related, and so Petr Kastovsky will talk about that later today. Network Packet Broker is another very good example, and I think Acton has done some really good work there, and so that's another one that I would point you to, and that uses their version of the Sonic OS, right? Kind of customized for that application. So there really are, that's the beauty of P4 is the programmability that you really can customize it and tailor it for many different applications.
Any question from the audience? Or one more simple question: what's the main difference between the second generation and the third generation of the Intel Fabric system?
On the Intel Tofino Intelligent Fabric processors. So actually, maybe you can jump back to the roadmap slide, then I can address that. Yeah, right there. So the main difference, well, first of all, the architecture is common. It's the same match action pipeline across all these. And so that's a good thing, right? Because that makes the code very portable and migratable across all these different variations. The obvious top line difference is the the speed, right? So the Tofino 2 to Tofino 3 doubles the bandwidth from 12.8 to 25.6 total terabits per second. And with that, we also double the 30 speed. But the third thing I would point out is kind of relates to your previous question, is just the maturation of a lot of the software. For example, one of the big applications, we didn't have time to go deep on it today, but is the AI machine learning acceleration, right, for distributed training. And we have code available today to the P4 community that can be prototyped on the Tofino and Tofino 2. So you can start prototyping there. And I really see that coming to maturity in the Tofino 3 timeframe. So that would be another example where I think the kind of that higher speed and combined with the more mature software comes together for that AI ML training capability with Tofino 3.
Okay. Any question? Oh yeah, here we have other questions. Oh, we have a police asking a question right now.
Yes, I would like to about the form factor of the Tofino success and currently Tofino 1, with the form factor change, so it will be we are currently using Tofino 1. We have to lay out.
Okay, so the question is on the form factor change across the Tofino products?
Yes.
Okay, so I guess the quickest way to answer that question is that, like, the Tofino 2 package does go up to a 71.5 millimeter by 66 millimeter package. And the Tofino 3, the smallest version of that is that same 71.5 by 66 millimeters. And like I mentioned before, they both support the 56 gig SerDes, right? So that's an easy transition. And then the high end Tofino 3 with the maximum capability, 25.6 terabits per second, that will have a larger package. That goes to 92.5 by 92.5 millimeters. So it is a bigger package to get up that 25.6. Now, as to whether or not they're pinout compatible on that 71.5 by 66 version, I don't know that. I haven't investigated that, but you know, I will say we did kind of keep that similar. If you want to migrate those easily, and then if you need to go to the 25.6, then it would go to a bigger package.
All right, I think we're out of time. Thanks, Todd, for the great talk. So, Todd, thank you for the sharing of the Intel Intelligent Rendering Vision technology. I think that's it. Yeah, thank you again.
Okay, thank you all very much, and enjoy the rest of the day there. I hope you all have a good workshop.
Thanks.